reminder, we're using logarithms because the numbers that you get are a little bit more interpretable. Underflow is less of an issue. It generalizes to the linear models we'll be talking about next, and addition is cheaper than multiplication. And so rather than multiplying a bunch of probabilities together, we'll just add the logs together. The first thing that we need to do is we need to create the base case. And the base case is just taking the score of starting a sentence with a particular part of speech with the score of that part of speech emitting that word. So we add those numbers together, and in the data set that we use to train this, we get higher scores for verbs than for other parts of speech starting a sentence. And so then to continue this, we now have our base case score that we computed on the previous slide, and we're going to extend that with the goal of filling in each of the cells of the best score for getting to the second position in the sentence, which is the word and add in the score for going from whatever that previous part of speech was to conjunction. And so we're just going to fill in the conjunction score of the second position of the table for the moment. To go from verb to conjunction, we add in negative 1.65, and we get the score of negative 5.21. For other parts of speech, these scores are all going to be far less, and because we're going to later take the max, we can forget about those for now. And then we do the same thing for going from a modifier to a conjunction, a determiner to a conjunction, and a conjunction to a conjunction. So these first three cases here. The best score that we get is negative 5.21. Look at what is the score for outputting and as a conjunction. And that's minus 0.64. And so we get a total score of negative 6.02 for the best way that we can label the second word in the sentence ending in conjunction as a tag. We can then do the same thing for the rest of the sentence. We need to keep track of, however, the breadcrumb. So like in choosing what was the best part of speech to get us to this position, it was verb that got us here, so we'll need to remember that going forward. So we keep doing this for the rest of our sentence. I'm only going to highlight the things that end up being the best reconstructions. And so here, we can go to the very end of the sentence, see what has the highest score, and in this case, it's ending the sentence in a pronoun. It is a pronoun. And so then we look at this breadcrumb, and that says go back to verb. And so we look at the verb breadcrumb, and that says conjunction. Then we go to the conjunction breadcrumb, and that says verb. And now we have the labeling of our sentence. And that labeling is verb, conjunction, verb, pronoun. And so now the question that you should be asking is, where the heck are all of these numbers coming from? I said that you could estimate them using an HMM, doing the simple sorts of counting tricks that we did before for naive Bayes, but that doesn't necessarily work so well. And so we're going to talk about how to learn these using a discriminative model. So an HMM is a generative model. To get there, we first have to talk about the perceptron. And so we'll eventually learn these scores using the structured perceptron, but before we get there, we need to talk about the generic perceptron first.